Today, we're going to be looking at patterns in algebra and looking at simple matchstick patterns. What we're going to do is come up with an algebraic rule, but really understand where the rule comes from. We're going to look at one that is really popular in schools. We're going to come up with 3 generic questions that you are asked in school a lot with patterns. So we're going to look at this linear pattern where it has 1 block and 4 sticks, and then 2 blocks with 7 sticks, and 3 blocks with 10 sticks. So what we're going to do with these blocks is we're going to figure out how many sticks are in the next diagram, how many sticks are in the 10th diagram, how many sticks are in the 20th diagram, and then we're going to write an algebraic sentence that describes the sentence, or that describes the system. But we're going to work a little backwards. We're going to start with an algebraic sentence to describe this system and then go back to our first question. So I've already drawn out our blocks and written the number of squares with the number of matches. So let's count them to make sure. Let's look at our first square. Let's count the sticks. 1, 2, 3, 4. 4 sticks, or matches. Okay, let's look at 2 squares. 1, 2, 3, 4, 5, 6, 7. 7. 3 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So by looking at this, we can easily tell that they are adding 3 each time. So we can easily look to see if we added on another square, how many matches there would be. 13. So in order to find the 10th square, we can go plus 3, plus 3, plus 3, all the way to 10, or we can come up with an easier equation to help us so where we don't have to add plus 3 each time, or we can easily just draw in extra sticks, but that would take a really long time. So let's look at a different way that we can write 4, which is 3 plus 1. Another way we can write 7 is 3 plus 3 plus 1. And another way to write 10 is 3 plus 3 plus 3 plus 1. So looking at the first square, and if there are 4 matches, we can tell that there's one group of 3 plus 1. Looking at 2 squares, we can tell that there are 2 groups of 3 plus 1. And looking at the 3 squares, we can tell that there are 3 groups of 3 plus 1, which essentially is the same as multiplication. So we can write 3 times 1 plus 1, 3 times 2 plus 1, and 3 times, what's a plus sign? 3 times 3 plus 1. So looking back at our questions, we know that the written sentence, or the written algebraic sentence for this would be m equals 3s plus 1. The m standing for matches and the s standing for squares. So let's look at our table. So we know that 1 square has 4 matches, 2 squares 7, 3 squares 10, then 4 squares. So if we take m equals 3, 4 plus 1, we know the answer is 13. So let's write 13 here. And exactly right here. M equals 3, that's a 10th. M equals 3, 4 plus 1, which is 13. Now let's look at how many are in the 10th spot. So we know that if we do m equals 3, 10 plus 1, our answer is going to be 31. Right here, m equals 3, times 10 plus 1 equals 31. Now looking at our 20th. M equals 320 plus 1 equals 61. Did I write it right? 61. So, from looking at this, we already stated that our algebraic sentence for the system is m, which is matches, equals 3 times the number of squares plus 1. I don't know what to say.